Recall from our previous class, we talked about distance on gray circles, and then we were told that distance is said to be on a gray circle if the 2 points in question are located on the same longitude. So in this case, we want to look at the case whereby the points are not on the same longitude, rather they are on latitude. Remember, for latitude, all lines of latitude except the equator are small circles. So if the 2 points in question are on a latitude that is not the equator, that means the distance to be calculated is distance on a small circle. So how can we do that? The only difference here is that instead of using this formula, which is theta over 360 times 2 pi r, in this case, we will replace this r. Remember, for a small circle, we use small letter r, and small letter r is related with big letter r as r equal to r equals alpha, where capital R is radius of the earth, and alpha is the latitude in question. So whenever we are calculating distance on a small circle, the distance becomes theta over 360 times 2 pi r, where this r is r plus alpha. So replacing this, it will be theta over 360 times 2 pi r cos alpha. Let's take some example. P and Q. P is on latitude 32 degree north, longitude 47 degree west, while Q is latitude 32 degree north, longitude 28 degree east, on the Earth's surface. Given that pi is 3.142 and r is 6,400 kilometers, calculate A1, the radius of the parallel of latitude through P. Then 2, the distance between P and Q along the parallel of latitude. B, if it takes an helicopter 9 hours to travel from P to Q, calculate its speed correct to 3 significant figures. Let's move the question up here so we can look at it. So first of all, we need to draw a question. Let me draw it here. Need to draw the sphere, then put those points. This is my prime meridian, and this is my equator. And point P is on latitude 32 degree north. And we assume 32 is here, degree north. But longitude 47 degree west. West is here. Let's assume this 47 degree west. Where the lines meet, longitude and latitude meet, give us point P. On the other hand, Q is on latitude 32 degree north, but longitude 28 degree east. I'm going to assume it here is 28 degree east, where the latitude and the longitude meet, give us point Q. So the first question says we should calculate the radius of the parallel of the latitude. Question A, radius r of the parallel of the latitude is capital R, the radius of the earth, multiplied by the cosine of alpha, where alpha is the latitude in question, 32 degrees. So that will be 6,400 multiplied by cos 32 degrees, which is 6,400 times cos 32 is 0.8480. 8480. 6,400 multiplied by that, we make 28 kilometers. That is the radius of the parallel of latitude through P. Then the B part of that question is the distance between P and Q along the parallel of the latitude. This distance here is a distance along a small circle, since the 2 points are on a small circle. This latitude here is a small circle. All lines of latitude are small circles except the equator. It's only the equator that is a great circle. So because it's distance along the small circle, we use the formula and we call it distance Q is theta over 360 times 2 pi r, small r because it's a small circle. And we know that small r is capital R cos alpha. So this distance now becomes theta over 360 times 2 pi r cos alpha, which will be, now let's get the angular distance between the 2 points. In this distance PQ, the angle between them, this angle here, that will be this longitude added to this longitude. So they are in different locations. This is west, this is east. So theta will be 47 plus 28. 47 plus 28, 7 plus 8 is 5. 15, right? But carry 1. 1 plus this 3. 3 plus is 75. So the angular distance between them is 75. Therefore, distance PQ will be 5 over 360 times 2 times, what did they say we should use for pi? 3.142. 3.142 times r cos alpha is already here, which is 5,428, which will give us, when we multiply all of that together, have 2557.8, 39.36, and divided by 360, which gives us 7105.1, so approximately 7105 kilometers, the distance between P and Q. Then the question went further. B, it says if it takes an helicopter 9 hours to travel from P to Q, calculate its speed correct to 3 significant figures. We know that speed is distance over time. Speed is equal to distance over time. The distance between P and Q is here, which is 7105. The time taken for the helicopter to travel is 9 hours divided by 9. So this divided by 9 gives us 789. 789.5 kilometer per hour. If I round it up, that would be 790 kilometer per hour. 8, they say to 3 significant figures. 8, of course, so this my rounding up is okay. 3 significant figures. According to the question, calculate its speed correct to 3 significant figures. So this is 790 correct to 3 significant figures. And let's move on to more examples. Example 2 say A and B are points on the parallel of latitude 68.7 degrees south. Their longitude being 124 degrees west and 56 degrees east, respectively. What is their distance apart measured along the parallel of latitude? First of all, we need to represent the latitude. So we draw the sphere, then this is a prime meridian, and the equator, 0 degree. A and B are points on the parallel of latitude 68.7 degrees south. Let's assume this is 68.7, 68.7 degrees south. Their longitude being 124 degrees west, 124 degrees west, and 56 degrees east. 56 degrees east. respectively. What is their distance apart measured along the parallel of latitude? Let me put the pointers. This is point A, where the latitude and the longitude meet. Then point B, where the latitude and the longitude meet. So the question says, what is their distance apart? This arc length here is the distance apart. We need to know the angle between them. This angle is the sum of this longitude, because the longitude are in different locations. 24 degree, 124 degree west and 56 degree east. So theta will be 124 plus 56. 124 plus 56 give us 180 degree. The distance along the latitude will be distance. That is distance AB. Let me call it that AB. The theta over 360 times 2 pi r, small r, because it's a small circle. But small r is big R cos alpha, where alpha is the latitude, which is 68.7 degree. So with that, you can put in the value. Theta is 180 over 360 times r cos alpha, that is 2 times pi, which is 3.1. What are we to use? Yes, 3.142 times 6,400, then cos 68.7. That gives us 7,305.5 kilometers. And example 3, X and Y are two locations on latitude 62 degrees south and their longitude are 13 degrees west and 102 degrees west respectively. Calculate the distance between X and Y measured along parallel of latitude B along the route. So first of all, we represent the information in diagram. Is the prime meridian, the equator, 0 degree. Then X and Y are two locations on latitude 62 degrees south. 62 degrees south. When the assume that is 62. The longitude is 13 degrees west. 13 degrees west. And 102 degrees west. 102 degrees west. Calculate the distance between X and Y. This is point X, and this is point Y. The angular distance between them first this angle, theta, since the 2 points are on the same location, there is 102 west and 13 west. The longitudinal difference between them will subtract 102 minus 13, which gives us 89 degrees. So the angle between them is 89 degrees. The next thing now is to find the distance between them. Distance between X and Y, let me call it distance XY. It's theta over 360 times 2 pi r, where r is r cos alpha, and alpha is the latitude, which is 62 degrees. Therefore, distance y will be 89 over 360 times 2 times pi is 22 over 7 times r. Instead of using this, I'm using this 6,400 which is capital, then cos 62 into that will be, and then we put all of that into a calculator. Now 4669.4 kilometers as the answer. And finally, question 4. Example, look, still have the B part of this example said distance along great circle. How can we get that? Distance along great circle here will be is equal to theta over 360 times 2 pi r, which is 89 over 360 times 2 times 22 over 7 times 6,400. Value was 9945. I will put all of that into calculator. 9945 kilometers. The last example says an aircraft flies from point P, latitude 40 degree north, longitude 38 degree east, to another point Q, latitude 40 degree north, longitude 22 degree west. Thereafter flies to another point R, latitude 28 degree north, longitude 22 degree west. Calculate distance between P and Q along their parallel of latitude, the distance between Q and R along the line of longitude, the average speed of the aircraft for the whole journey. Then the prime meridian might as well look like orange. Then the equator 0 degree. The aircraft flies point P is 40 degree north. Let's assume this is 40 degree north. Longitude is 38 degree east. 38 degree east. R is point P. To another point Q, 40 degree north also for 22 degree west. 22 degree west. This is 22 degree west. So this is point Q. Thereafter flies to yet another point R, 28 degree north, 28 degree north. This is 28 degree north. For longitude, 22 degree north. Okay, the same longitude at this point. This is point R. Point R. Calculate the distance between P and Q. This distance here. This distance along a small circle. Let's get the angle between this and this, which we get by adding the longitude. So the longitude are different locations, 22 degree west and 38 degree east. So the theta there in that case, distance between P and Q, the theta there will be 22 degree plus 38 degree, which will give us 60 degree. 60 degree. So that the distance there, which is theta over 360 times 2 pi r, small r because it's a small circle. The distance here is distance along the small circle, but r, small r is capital R cos alpha, where alpha is the latitude. The common latitude is 40 degrees. So alpha is 40 degrees. Therefore, the distance is 60 over 360 times 2 times pi. What I would use for pi? 3.142. 3.142 times using r cos alpha, which is 6,400 cos 40 degrees. So by the time I plug in all of this into a calculator, I have 5,134 kilometers of distance between P and Q along this small circuit. Then the D part, the distance between Q and R along the line of longitude. This distance right here, this distance between Q and R. In this case, we are talking about distance along a gray circle. We need to get the angular distance between the two of these things. To do that, we subtract the two latitude, because they are in the same location, 40 degree north and 28 degree north. So that theta there, 40 minus 28 degree, and distance along a gray circle. So distance QR is theta over 360 times 2 pi r, which is 12 over 360, 360 times 2 times 3.142 times 6,400. And the time we plug in all of that into a calculator, 1,341, 1,341 kilometers, and the distance around QR or along the gray circle. Finally, question C, the average speed of the aircraft for the whole journey. You know that average speed is total distance traveled over total time taken. Speed is equal to total distance traveled over total time taken. So what is the total distance here? Total distance will be the distance between P and Q, which is 5,134, 5,134 plus the distance along the gray circle, that is distance from this point QR, which is 1,341. 1,341. By the time we add all of that together, we have 6,475 kilometers. Therefore, average speed is equal to 6,475 divided by, what was the time? So the average speed of the air travel takes 12 hours divided by 12. By the time we do this division, we have 539.59 kilometers per hour. The nearest whole number, that is 540 kilometers per hour.